Okay, so it's a relativity problem. The first question is asking how much time does the trip take as measured in the Earth's frame. So we would use that distance in the Earth's frame is equal to the velocity times the time measured in the Earth's frame, right? Now, let's see if I rearrange this. We get that the time is equal to the distance, which is 450 light years, divided by the speed, which is 0.98 c. Now it turns out that a light year is the distance that light travels in a year. So if you divide by the velocity relative to the speed of light, you get your answer is 460 years. Okay. I mean, if the velocity under here were just pure c, it was just the speed of light, then the time it would take to go 450 light years would be 450 years. Since we're going a little slower than that, it's 460 years. If you want to actually see it multiplied out, well, 450 light years, if I convert into meters, is 4.257 times 10 to the 18th meters, and then we're going to divide that by 0.98 times 3 times 10 to the 8th. Okay. And we get 1.448 times 10 to the 10th seconds, and then I convert that to years. And I get 460 years. Okay, so it works. But you don't need to do that. It just helps to see it sometimes. Alright, so for part B, how much time does the trip take as measured in the ship's frame? Well, moving clocks run slow, so the time on board the ship is going to be the time measured in the rest frame, or the proper frame, or Earth's frame, divided by gamma. Now gamma, 1 over the square root of 1 minus b squared over c squared. Okay, so I'm going to go ahead and work this out just so you can see it here. So it's 1 minus 0.98 c squared over c squared, right? Now the c squared and the c squared cancels out, but you still have the 0.98 squared. So it's 1 over the square root of 1 minus 0.98 squared, which is 5.025. Okay? So the time as measured in the ship's frame is going to be less. It's going to be 460 years divided by gamma, which is 92 years. Now part C, how far does the ship's travel as measured by the ship's odometer in light years? Well, we'll say d on board the ship is equal to the velocity times the time on board the ship, right? Anytime you use distance equals velocity times time, whether it's up here or down here, you got to make sure that the distance and the time are measured in the same frame for your answer to make sense. Okay, so it's 0.98 c multiplied by 92 years. And again, we can take advantage of the speed of light, that if this were just c, then this would be 92 light years. But we're a little less than c, so it's 90 light years. That would be the distance. And if you want, you can go through this mess and get that yourself. But that's all we need to do.